Have you noticed a strange thing? Before, you would simply stick seedlings into the ground, and they grew. Now you do everything by the book. Buy good seeds, expensive soil, fertilizers, water more often. Yet the plants seem to be living on their last breath. The leaves are pale, the edges dry out, the tomatoes stand thin and weak. Strawberries produce small berries, and after rain puddles sit on the beds like in a parking lot. And the most worrying sign, you dig into the soil and there are almost no earthworms. This is the moment most people miss. They think, not enough fertilizer or bad variety. But in reality, at this point, the problem is no longer in the plants. The problem is that the soil has stopped being alive. Adult gardeners in the United States often tell the same story. A person moves into a house, and for the first year or two, everything grows beautifully. Then gradually, strange things begin. Water stops soaking in. Mulch lies for months like straw. Compost does not disappear. And plant roots grow sideways instead of downward. You water. And the next day, the ground is dry and hard again, like ceramic. And this is where the mistake happens. At this moment, almost everyone starts doing the same thing, adding more fertilizer. But fertilizer is food for the plant, not for the soil. And the plant, honestly, does not really know how to feed itself. Microorganisms feed it. Underground, there must exist an entire system: bacteria, fungal threads, microscopic organisms. They break down organic matter and turn it into available nutrition. They hold moisture and make the soil rechloy, loose and friable. When they disappear, what many people see in their yard happens. The soil looks like soil, but behaves like dust mixed with cement. Why do they disappear? Chlorinated water from the hose, regular digging and tilling, chemical fertilizers, herbicides, clean decorative lawns without organic matter. All of this gradually kills soil life. Not immediately. That is exactly why people do not connect cause and effect. The soil dies quietly, over several seasons. Here is a typical example. A person waters in the evening, comes out in the morning. A crust has formed on top. They think, I need to water more often. But in reality, the water simply cannot penetrate inside because the channels created by bacteria and fungal networks have disappeared. There is no one left to make them. This is where the first truly effective method often mentioned by proponents of natural gardening appears: fermented rice water. It sounds too simple, which is why people usually do not believe in it. But its principle is very specific. Lactic acid bacteria naturally live on the surface of rice. When rice is rinsed and the water is left for several days, a mild natural fermentation begins. In this liquid, a colony of living microorganisms appears. Essentially, it is a starter culture for the soil. When this water is poured onto a garden bed, it is not a feeding, it is colonization. Microorganisms begin to multiply, populate the upper layer of the soil, and then a chain reaction begins. They process organic residues, create microchannels, attract other soil inhabitants, and trigger the return of the ecosystem. And here is the effect most often noticed first: the behavior of water changes. Within a few days after watering with it, the soil stops repelling moisture. It no longer sits in puddles, but moves inward. Not because it was washed through, but because micropores appeared. They are created by bacteria and fungal threads. Next, the crust after watering begins to disappear. Then, unexpectedly, the soil begins to darken. Then worms appear. And worms are the main indicator. They come only where there is life. Many people are surprised. But I didn't fertilize anything. That is exactly the point. Plants often are not lacking fertilizer. They are lacking the intermediaries that turn organic matter into nutrition. And then what at first seems like coincidence happens. Seedlings that stood still for weeks begin to grow. The leaves become thicker and darker. Watering is needed less often, and the mulch begins to disappear. Not because it blew away, but because microorganisms ate it. So the key idea to understand is this: healthy plants are not the result of fertilizing. They are the result of living soil. Next, we will go over how to properly prepare this simple liquid and why it often becomes the first step toward restoring even tired, concrete-like yard soil. But first, I want to introduce you to one more method, because reviving the soil is only half the job. Many gardeners stop exactly at this stage. The ground becomes softer, water begins to go inward, worms return. Yet the plants still do not show the vigorous growth they expected. They no longer die, but they do not bring satisfaction either. Why does this happen? Because soil life is the kitchen, but plants still need signals that it is time to grow. In nature, fertilizers do not give these signals. The plants themselves do. There is an interesting observation often mentioned by proponents of Korean natural farming. If actively growing grass is near a young sapling, it begins to grow faster. For a long time, this was considered simple competition or coincidence, but later another explanation was suggested. Plants release biologically active substances into the surrounding environment. Natural growth hormones. This is what the second method is based on: fermented plant juice, often called FPJ. Essentially, it is an extract from young, fast-growing plant shoots that has undergone gentle fermentation. Not compost, not an infusion, not a fertilizer. It is specifically a growth signal. Actively growing greenery is used, for example, young weeds, nettles, pumpkin shoots, or legumes. It is important that the plant is in a phase of rapid growth, when it is stretching upward, soft, juicy, literally bursting from the ground. At this moment, it contains the maximum concentration of natural stimulants, auxins, enzymes, and sugars. When the greens are layered with sugar and left for several days, the cell sap is drawn out and begins to ferment naturally. The result is a dark, aromatic liquid. And here is the key point. This liquid contains almost no nutrients in the usual sense. There are no large doses of nitrogen or phosphorus. But when it is diluted and sprayed onto plants, a noticeable reaction occurs. The leaves become denser, internodes shorter, and growth more active. It is believed that the plant perceives it as a signal. Active life surrounds it. Conditions are favorable, and it can build green mass. Therefore, the two methods work together, but differently. Rice water populates the soil. Plant juice talks to the plant itself. Now about application. This is where mistakes most often happen. With rice water, everything is simpler than it seems, but there is a nuance. It is not poured every day, and the bed is not turned into a swamp. It is prepared like this. Ordinary white rice is rinsed in water, lightly rubbing it until the water becomes milky. This water is left in a warm place for several days until a light sour milk smell appears. Not rot, not a sharp stench, a mild sourness. This means lactic acid bacteria have multiplied. Before use, it must be diluted with water. A liquid that is too concentrated will not speed the process and may temporarily suppress the roots. It is poured not right at the stem but across the soil surface, preferably in the evening or on a cloudy day. The main mistake is expecting an immediate result the next day. Soil changes gradually, but the changes are stable. Now FPJ. The greens are not washed. Natural microorganisms live on them. They are finely chopped, mixed with an equal amount of sugar, lightly pressed and covered, but not airtight. After a few days, a syrup appears. It is strained and stored in a cool place. It is used in a very weak dilution, literally a few spoonfuls per bucket of water. This is important. It is not feeding, but a signal. And overdosing does not accelerate growth. It is applied either by spraying onto the leaves or by light watering around the plant during active growth. Not in heat and not under direct sun. And one more common mistake is using it on sick plants. It does not heal, it stimulates. So first restore the soil and then give the growth signal. When both methods are used correctly, the picture usually changes as a whole. The soil begins to retain moisture. Watering is needed less often. Plants produce darker foliage, and flowering becomes calmer and more stable. And most importantly, the feeling that you are constantly fighting your plot disappears. It begins to work together with you. And now we come to the point that garden store advertisements usually don't mention. Even when the soil has begun to awaken and the plants respond with growth, over time many people notice again that the plot seems to be slipping backward. In spring, everything goes perfectly. The leaves are rich, the shoots vigorous, but by mid-season, a familiar picture appears. The top layer dries out faster again. Watering has to be more frequent, and the plants look as if they are using their last strength just to make it to autumn. This is the main sign. Life has appeared, but it has not yet stabilized. We have started the process, but we have not created a sustainable ecosystem. And this is where the third method comes in, which in natural farming is often considered decisive: compost tea. It is easy to confuse with a simple compost infusion. So many people try it, see no difference, and become disappointed. An infusion is just water in which compost has soaked. Compost tea is when you deliberately multiply living microorganisms and transfer them into the soil as entire communities. Imagine what forest soil looks like after rain. It is soft, smells fresh, springs underfoot, and never turns to concrete, even though no one loosens it or fertilizes it. The reason is not the leaves, but the enormous number of bacteria and fungi that live there constantly. It is precisely these that gardeners try to transfer when preparing compost tea. They take mature compost, the kind that smells not of rot but of warm earth after rain, place it in water, and add a little sugar or molasses so that the microorganisms have something to feed on. But there is a key detail that is often overlooked. The solution needs air. It is stirred or aerated because beneficial bacteria and fungal cultures develop only in the presence of oxygen. If the bucket is left standing, another process begins, and the benefits are minimal.